I'm Vijay Pandirajan, Sloan Fellow 15, also Vice President for Orbit Spot. So what we'll be talking about today, as you know, in the next 45 minutes is IoT, the new ecosystem. We've got a great speaker. I'm pleased to introduce our speaker, Ryan Mallory, Global VP Technology from Equinix. Thank you.
Thanks, Vijay. Thanks, everybody. We'll go ahead and dive in real quick. It's a pleasure to be able to spend some time with you this afternoon. We're going to dive into IoT and some of the focus points we see from a unique perspective out in the marketplace. So we're involved with companies of all sizes and shapes trying to become relevant and utilize the IoT ecosystem that's developing out there. When we're starting to engage with customers and we're talking with them about understanding, do they have an IoT strategy and what their focuses are, there's some key points that we try to make sure that they're thinking about. What is IoT to my business? How does it relate to it? Do you have a product set that's relevant today, or are you trying to deliver something that has the potential to be relevant in the future? Another area is, are you prepared? Do you have the performance capabilities built into your network, built into your application, and built into your services that enable your capabilities to be relevant? More importantly, probably the largest aspect that everybody needs to take into account is security. When you start looking at your security impact zone and we start talking about how you segment your traffic flows and how much access to data there is out there, security is the primary point everybody should be considering. And do you need control? I think everybody in here would answer yes, based on just the type of crowd we have here. In the overall IoT business models that are evolving, there's three key points you need to start looking at to understand what's going to be relevant to you, what's going to be relevant to your customers, and how you stay in tune with addressing that information. One is having access to the info. You've got to have the ability to gather and analyze the traffic. You need to be able to make informed decisions with the information you're gathering, and you need to execute in a rapid manner. So let's talk about this a little bit. So when you're gathering the information, this is from the multitude of sensors and capabilities that are out there in the marketplace. If you think about the connected car, you have road sensors that are out there on the roads today checking speed, cameras, CCTV. You also have your car that's tied into MyLink, different types of services that the different manufacturers have that tell you the health of your car. All of this information is being gathered. You then have to have the ability to act on that information and understand what's coming at you. There's information that's relevant and there's information that's just nice to have. Having the ability to disseminate that is extremely important, but none of this becomes relevant if you can't act on it in a rapid manner. So having people that have access to that information around the globe, have the ability to make decisions and then move on it is extremely important. These are the three capabilities of an agile business model in the IoT environment. When you start to look at and evaluate what your IoT strategy is, look at it from a local, a regional, a national, and a global perspective. At the heart of all IoT strategies has to be carrier neutrality and interconnection. You've got to find those interconnection points where you can leverage top-tier carriers, access to cloud providers, and customers in all three locations. Understand what your footprint needs to look like and be able to act on that. This starts to build into some of the concepts we're going to talk about here in the next few slides around limiting your security impact zone. Having access to the companies inside these carrier-neutral interconnection facilities become extremely important. Historically, it's been with fiber cross-connects going from one service provider to the other, one customer into a service provider, a one-to-one type of integration model. What we've seen over the last several years is with advancements in switching fabrics and some of the SDN automation or the SD-WAN capabilities, is the ability to utilize infrastructure at a logical level versus a physical level to be able to distribute your services in a near real-time basis. So when you start looking at your deployment models in specific regions and you want to utilize different cloud providers or service providers like a ServiceNow, a Workday, an ADP, understand how you can aggregate those services, tie them into a single switching fabric, then use SDN, NFV type capabilities to auto-configure access to those different cloud providers that are out there and service providers. This becomes the core for trying to define agility in how you're going to execute. This shortens your time to market and allows you to more predictably influence your ROI from a network perspective. With that said, don't move away from all of the cornerstone technologies that have been out there. The internet exchanges are proven, the cost structures are going down, and the reliability is going up. It's important to have dedicated cores. You have the flexibility to have different service capabilities on the edge. Don't overlook some of those technologies that are out there. More importantly, make sure that you're looking at different ways to connect. API integration, containers, container technology that's out there allows you to have the flexibility to provision directly into services. You don't need to go through and run manual provisioning, manual capabilities between different service providers. Utilize the technology that's out there. Apogee provides a great API stack. Everybody's probably familiar with Docker containers. You have the ability to move your workloads into infrastructure that will help you mature your product, develop your product, and execute on your product. Taking a look at this from the other side, you're now starting to build your core infrastructure. You're looking at the distribution around the globe. Now you need to look at who do you need to connect with. There's some core areas that you should focus on. One is around cloud. What type of cloud services do you need? Are you interested just in compute? Are you interested in compute and storage? Do you need a more dynamic stack that includes internet access, that includes firewall capabilities, that includes a CDM type model? Understanding what that profile looks like will help you understand where you should deploy and what type of partner you should choose from a cloud perspective. Content distribution allows you in the IoT marketplace to not have to deploy a large-scale stack everywhere you go. It allows you to cache and distribute information that's relevant to what you're trying to analyze and act on. And the network. You've got to pay attention to the network providers that are there. So the days of going out and saying, I want a single MPLS network globally, I think are starting to wane. We need to know and understand who the highest scale providers are, who the tier 1 providers are, to ensure we have the capabilities for high capacity transport between locations. You don't have to just settle for low speed MPLS. You don't have to just settle for low speed services from a cable company. Know and understand who's on net, understand how they're going to connect, and that the cost models associated with Ethernet and cable-based services continue to drop while the throughputs continue to go up. We're seeing speeds of over a gig to endpoints, whether it's a consumer-based home or small office, being deployed very rapidly around the globe. Are we prepared? When we start thinking about the continuum of change that we've seen in the interconnected industry, in 1982, Time Magazine awarded the PC the Person of the Year. So that's when this all started. That's when this continuum started. Over the past couple decades, we've seen the network and the connected era starting to take shape. This was the rollout of the internet in a commercialized fashion. This was the utilization of internet-based services for a marketplace type model. We're now in the interconnected era. When you start thinking about how interconnected we are as individuals, it's really unbelievable. Think about how tied to your phones, to your Apple Watches, to all technology you are. We're starting to see this transformation in this stage right now to new eras of interconnected and technology evaluation. I was just talking with a couple people here yesterday about some startups that I was having conversations with last week in Europe. So there's a view and a movement in Europe based on data sovereignty that PII, personal identification information, is a new revenue stream. That's the information companies from social media and search engines are scraping from you and then using to sell to the ad exchange information or push content towards you. The view in Europe is that's your personal information, that should be a revenue center to you. They want to block that, therefore not distributing it to those type of companies without your permission and feel you should be paid for it. So we're seeing this transition in the interconnected era of the value of the individual and the value of content continue to go up as we continue to become more interconnected. When you look at IoT from a deployment standpoint, you've got to start looking at a segmented network. The Iot Edge and the IoT Core. The Iot Edge is where you're going to integrate all of those endpoint traffic, all of the sensors, all the information that's going to be gathered into centralized locations. So these can be distributed interconnection points, or they can even be a sub-edge that sits out a little bit further. So all the data that comes in should sit in your Iot Edge. The key here is to make sure you start to look at and realize your security impact zone. By segmenting the traffic, you're starting to limit or lower the exposure to your security impact zone. You're able to get better performance on the edge by shortening the distance. As we start to see the rollout of 5G, applications have to have a 1 millisecond response time. So you have to have capabilities and access close to the edge that you can respond to. You don't have to then transport all that information. You can cache it and store it, run algorithms that scrape the right information and push that back into the core. The core is where you're going to start to optimize the high-level connectivity, the high-level transport that different providers have available in these interconnection points. If you start looking at a distributed model, you have aggregation and transport at very high speeds that will allow you to access and act on the data that's becoming relevant. We've done several different case studies with large medical institutions around the evaluation of DNA and what it used to take to move that information across the globe. They can now, or across the country. They can now do that in a matter of hours instead of weeks. You have access to 400 terabit type circuits out there from a transport perspective right now. Optronics and cost cards are going down. The amount of capacity continues to go up. And in this competitive nature, in these high capacity interconnection points, you have the ability to negotiate with carriers in a very competitive marketplace. Start thinking about segmenting your edge and your core with a primary purpose of lowering your security impact point, more importantly, being able to drive cost efficiencies in how your applications perform, your user experience, and the way your information is going to be transported. This is very, very key for an IoT deployment model. When we start looking at challenges and capabilities associated with IoT, they're segmented into 4 key points: scale, integration, gravity, and security. Like I said earlier, security is the primary focus everybody should be worried about. Think about a home user. You've got a Nest thermostat. You've got a Wi-Fi enabled refrigerator. Your son or daughter has an Xbox. Every one of those devices are connected to your Wi-Fi. You go home, log into your PC, get an SSL tunnel directly into, start looking at Salesforce, looking at your CRMs, looking at financial data inside your company. You've now potentially exposed your entire internal LAN to a security breach. We're trusting that Google, based on its name, has secured Nest. We're trusting that the Microsoft has secured the Xbox. And we're trusting that LG has secured your refrigerator. It's a lot of trust to be putting into other companies when it's your job and your reputation on the line. Start thinking about the security impact zone and how we can mitigate that exposure. When you start to create this distributed or centralized model where you have interconnection points in the middle, in essence, you're building virtual DMZs out in your overall topology. You're able to address and limit and lower your security impact zone by putting aggregation points around your network. So this isn't re-engineering your application, so to say. This is putting in essence, a DMZ in the regional locations that will allow you to be able to start to control and aggregate traffic, analyze the traffic, and cleanse it where need be. So you have the potential here to start putting in your firewall capabilities. You can also start to do your DDoS mitigation, as well as create different types of service gateways from a cost modeling perspective. Taking this one step further, I wanted to show in a graphical representation what that type of distributed architecture looked like. So if you start deploying the nodes, you have data hubs or performance hubs depending on the size. So a performance hub could be a single rack deployment where you may have a new presence in a market, or you may be looking to penetrate a new type of user base. So you can go out, you can put a single rack out there, you can put your you can put your router, switching device, firewall. That becomes your edge aggregation point. This allows you to aggregate mobile users. It allows you to aggregate any type of inbound traffic, lowering your security impact zone to your core. This also gives you access through some of those dynamic switching fabrics we talked about previously to cloud providers and some of the other solution providers that you want to access inside the data centers. Being able to tie them together with the high capacity links ensures that A, you have a DR strategy in place for capacity associated with site-to-site replication, and you also have the ability to transfer the type of files and information you need between locations. This type of core has become extremely affordable and oftentimes can help drive your entire IoT or cloud-based strategy. Look for tier 1 providers, understand what your current throughput threshold is, and start looking at where you can take that. So when you start looking at the practical deployment of what we're seeing out in the marketplace today and how these different types of capabilities are being put into a real world use. So as we started to look at IoT deployments or IoT strategy for healthcare systems, we sat down with them and we said, okay, let's start talking about what your OT, your operation technology is. Where are you putting your infrastructure, your bare metal, your servers, your routers, your hardware. Some of them had it in-house, some of it had it in data centers. So you had a silo of individuals that were working on your OT. You then had your MT, which is your manufacturing technology. This is the services, the RFID healthcare services, whether it's a trach tube or bandages that get scanned every time they go into a room before they come out of the cart, they shoot them. So you had a manufacturing technology that was tied back into a digital supply chain. And then you had the IT. All of them were working in silos. None of them were really communicating together to make sure there were efficiencies built into the overall service chain model, and to make sure that they were communicating to say, hey, listen, we've got factories here, we've got distribution sites here, I've got hospitals here. How do we make this a dynamic type of network ecosystem to help that start to develop, so I don't have to have a nurse walk around at the end of every shift and try to count how many bandages that I have inside a cart, that I don't have to have my IT guy fly in every time one of the record system for check-in crash. Being able to aggregate those three through a centralized aggregation point and share information, whether it's tied in through APIs or switching fabrics, ensures you're starting to flatten out those segregated silos from a vertical perspective. More importantly, once they start talking about what type of destinations, where their service models are hosted, it became very quickly apparent that they were using a lot of the same underlying cloud providers, as well as solution service providers for placing orders and processing capabilities. More importantly, we started to build synergies with different endpoint providers that were bringing solutions to them. GE was delivering IP-enabled light bulbs. They were delivering all kinds of pumping material and hardware medical material into the site. We started tying that from an MT perspective into the IT perspective, and all of a sudden they started to lower the overhead from a depot storage time for the information and the capabilities they had to keep in-house to being able to go to almost a near real-time deployment model. We were also able to start looking at other service providers like a Siemens that were able to become more dynamic in how they were able to address specialized service requirements for those hospitals. Do you need some type of a vaccine? Do you need to have another defibrillator? Do you need these type of capabilities in emergency markets that we weren't able to predict and project before? This goes back to my very first point. Having the ability to aggregate information, having the ability to analyze the information, more importantly, having the ability to act on the information. Being able to flatten the topology, remove the verticals, remove the silos, allow people to make those decisions in a near real-time basis sometimes, giving a better user experience at a more cost-effective price point. When you start looking at how you want to plan for ecosystem development or penetration into the overall IoT ecosystem, you need to think about three components. The endpoints. We've talked about profitable endpoints here. These are the service capabilities the MT, the manufacturing technologies are building and providing. It can be, like I said, light bulbs. It could be, RFID packages. It could be anything under the sun that falls inside that profitability window there that people are trying to sell out there. So that's the product they're trying to deliver out there. More importantly, you have to understand who the magnets are in that segment that's going to help enable that. This goes back to understanding your cloud service providers, your network service providers, more importantly, outside that realm, the complex solution enablement capabilities that you can bring to market to shorten your time to market and eliminate as many of the technical barriers as possible. You don't have to stand everything up in a wholly owned stack and try to bring that to market as an individual unit. Utilize the service capabilities that are out there. That starts to drive ecosystem development. We've seen 4 primary ecosystems develop over the last 18 years. The first one was the networks, and it started just out of necessity for internet peering. The second was financial, which was the buying and selling and trading of the exchanges. The third was the cloud. The fourth is IoT. It's typically taken about 10 years for an ecosystem to develop. Right now, based on market-based densities that we're seeing out there from the network and the cloud capabilities, it's shrinking to 5 or less. So the amount of evolution that takes place in these type of environments that are highly interconnected, highly service provider enabled, is developing at a much more rapid pace than it has over the past 20 years. So these are key components when you're looking to penetrate a market, bring a product to market that you need to keep into account or you need to take into account to ensure that you get the foothold you want and ensure that you have the capabilities available out into the marketplace. This is an example that we put together for a car manufacturer when we started to look at what their interconnected car model should look like. So when we start talking about the edge, you start talking about all the sensors that are out there. This is from, road sensors for speed enablement, like I said, CCTV, and traffic lights. In many states now, what's becoming even more important are charging stations for electric cars. So you're seeing that predictive analytics out there. How far can you go? Where are you at? This is all the edge information that's out there in the marketplace today from a sensor perspective. The extended edge that we talked about earlier is your aggregation point. If you had a centralized point or even 2 centralized point in any geographic region, the latency associated with getting this information all being aggregated at the edge, cached, and then taken back into a centralized core wouldn't allow you to act on the information quick enough. This edge aggregation model allows the information to be brought in, having some analytic capabilities in a micro-type deployment, analyze the information, and help you realize what needs to be pushed back to the core. So your core deployment then is where you can do some more predictive analytics, figure out what's important, what's not, more importantly, what needs to be stored longer term, and then utilize the access up into the key service providers, whether it's a cloud, network utilization for high capacity transport, or other service providers out there. This is a real world model that was put in place for multiple car companies right now as they're trying to get more effective in the mileage that they get for their cars, how often you need to change the tires, what you need to do from an oil change perspective. Is it 3,500 miles? Is it 10,000 miles? They're using this type of information in this tiered deployment structure to help ensure they're able to gather that information, analyze the information, and act on it as quickly as possible. When you start to talk about the Internet of Things from a platform and an ecosystem perspective, I have people that ask me, is this something new? Is this something that's still starting to build momentum? My answer is always no. We've seen the overall ecosystem developing for the last 20 years, and it's not about the endpoint. So it's hard to see up here, but the endpoints up here, so the sensors that we've been talking about, the aggregation points, they are new. So Fitbit, Apple Watch, Nest, these are the endpoints that are out there that have come to market recently over the last couple years that we've seen develop. Everything that sits inside your extended edge to your dynamic core, these are companies that have been around. Their product sets continue to evolve to help enable the service that keeps being pushed out further to that extended edge. So this is not a new ecosystem from the standpoint that you're not seeing necessarily new IoT cloud providers pop up. You're not seeing necessarily new IoT internet providers pop up. You are seeing changes in their product sets that are allowing them to become more dynamic and nimble to address these type of densities at the edge. This is the overall ecosystem and marketplace that everybody is participating in today. Understanding how and where you should deploy your extended edge, your core, and minimize your security impact zone is what you need to start looking at in this overall tiered architecture inside an interconnection facility. I'll close with, when you're going through an IoT strategy session, you need to make sure that you're dealing with providers that have size, scope, and scale. The interconnected facilities that you're working in, make sure that they have the right level of connectivity, the right level of distribution, and the right level of penetration around the globe where your target markets are. Most importantly, make sure that they're financially strong. We're seeing a lot of turmoil right now out in these centralized aggregation points where companies are starting to exit the market, even very large name companies that had been incumbents in the business. Make sure you understand how they can impact, or how their financial impact will relate to you. It's not cheap to build these locations. Make sure they have the staying power to be around as long as your service providers will be. Most importantly, look for their ecosystem dynamics. Understand who's there, understand who you want to connect to. Most importantly, make sure that you have the ability to grow with them around the globe to help your products become successful. Thank you. We've got a little bit of time. Questions?
From a strategic perspective, what are some of the biggest mistakes companies are doing in trying to take advantage of the Internet of Things? What are some of the best and worst practices you've seen?
So it's the best and worst kind of straddle together. It's really size and scope. If you're going to try to build an IoT-based strategy, make sure you look at this from, in essence, a greenfield build as somebody who's trying to enter it. The components that are out there already exist. We see companies come in and say, I want to enter into an IoT strategy, but they say, I only want this tiny part of my business to do that. Well, it's very difficult to start to gain momentum and realize a return in that investment without trying to build a more comprehensive strategy. A lot of companies already have capabilities in place that they can utilize, so it's not trying to just look at this in a microcosm. Start looking at it at a macrocosm level, and then you can start to gain bigger momentum.
Hi there. I had a question partially driven by the image on the car ecosystem.
Yep.
So I'm just curious, and some of the other graphics help see this as well. To what degree do you see information sharing happening here? Is that just kind of the edge, the extended edge, to avoid kind of duplication? I mean, some of these pieces I saw being government generated, so how does that kind of fit?
So it depends on what the information type is. So if it's specific to an auto manufacturer, say Mercedes or Audi or Chevrolet, there's certain level of segregation, data segregation there. But when you start talking about access to information, car flows, the charging station, that information is becoming a lot more dynamic and easily available. And so I think you're going to start seeing that even more at the extended edge, especially as we start to gather more information around predictive analytics for what people are doing, what trains are on time, those type of capabilities. Once you start getting up in here, that's where you start to get your proprietary access, because you've already done your analytical scrape here. So this is the general gathering of information. Once it starts to go up here, that's something specific that somebody has an application written for that they're trying to drive.
Different question. I'm in medical device space.
Mm-hmm.
Where do you see organizational ownership of IoT? Because I feel that we are not organizationally structured, and aligned with that capability. Who really owns it and drives it?
That's a great question. So think of it in the scope of some of the insurance exchanges that are out there. You've got a lot of different players that are touching this. So it's typically the healthcare institution or the system will own it from a medical institution perspective, and they want to bring in then the medical technology and then the service providers into it. And so it's still a gray area right now, very similar to like the insurance exchanges that are out there. Who has data sovereignty? Who owns the traffic that's out there? How are you interconnecting? There's rules and regulations that are out there, but very similar to how we're trying to drive towards IoT towards that type of capability as well.
So we've heard the connected car, the healthcare IoT, and these type of use cases for a long time.
Uh-huh.
Part of the reason why companies struggle with the level of investment needed in IoT space is there seem to be these new use cases with very low return on investment or revenue opportunity, whereas there don't seem to be clear answers for those big use cases like the connected car. What are some of the use cases you're seeing as part of your research and your exposure to the IoT industry?
Sure. So we've seen it everywhere from key cards, people tracking key card access in hotels and trying to build more efficiencies into how their workforce moves through the different the rooms and where security is at and those type of things. That's more of a niche marketplace for hotel chains. So we've seen some of that. When you start to look at more data analytics for whether it's segmented sports or R&D development inside the medical field, not going into the whole hospital side, the gamut's out there. So, these are big examples because they are well documented and we wanted to touch on them. I've got a number of different ones where we deal very niche, from a niche access point, and a lot of it has to do with just, what is somebody trying to access, and then what are they trying to get to, that then we start to help collect data on. So it's everything under the sun, really.
Yeah, Frank Gillette from Forrester Research. In the work that we've done talking to CIOs, what we've found is every company has assets that are trying to maintain, and those come connected, but often they're all in different ecosystems. And then if you're a manufacturing company, you have your product guys doing something completely different, building IoT into a product.
Yep.
How are you seeing companies, and I'm not convinced it's necessarily happening with CIOs or at all, the research that I'm seeing and doing, how are they bringing together that sort of disparate notion of, well, the X-ray machine has one thing, and the drug cart has another, and I'm not seeing many software solutions in the market that lets you stitch together a view into a business process. So it feels like we're pretty early in the market. So I'm not seeing very many cases yet where it's as advanced as the connected car guys, where they're actually trying to get a cross-system view. I'm seeing all these little siloed instances with their own value proposition, but not a coherent one across the business, or even a coherent one sort of in the product line, if they have that.
I would say maybe 18 months ago, I would have agreed with you. We're starting to see more progression where you've got to have collaboration as you start to the digital logistics stream starts to become more automated. So we see API integration with different type of capabilities. I was talking with somebody earlier about ServiceNow. So you have companies that instead of having to place an order, push a ticket, or want to open something up where they say, okay, let me wait for a manual response and those type of capabilities. They want to tie each one of their departments through a ServiceNow interface, an API hook, into an overlying ticketing infrastructure that allows you to have dynamic access to what's taking place across all those different organizations, so you can track that. Is it definitely evolving? You bet. So we're starting to see progress, but over time, probably in the next 12 months or so, I bet you'll see some companies that come out and say, this is a portal interface that each company has their own cost center and can access the digital logistics stream that says, I need to order this, or we're working on this, how do we collaborate together? So we see that a lot out in Silicon Valley right now. Yep.
If you talk to Microsoft, they'll say they've got a hyper-scalable platform. Maybe AWS will say the same thing. What are the triggers? At what point do I need an interconnect partner if I'm just starting out, let's say, with my first IoT effort?
So when you want to look at what your interconnected partner capability should look like, it goes back to say, what do you want to virtualize and what do you want to own? And so look at either your app stack or your deployment stack, and you say, what do I really want to do? If I want to attack a segmented market, you may be able to have a single interconnection point, and that may be I can go to AWS. I can get a single VPC instance. I can use some of their internet access and their CDN services to be able to expose my product set out there. When you start looking at, I'm now getting orders at different times of the year. I want to be able to predict, at Christmas, at the holiday season, I get a massive influx for service orders, or when it's hot, I'm in HVAC, I get a massive influx. And you want to start having that burstability for cost perspective. You need to be able to have that understanding of these are my price thresholds for this, and this is my overall exposure if I want to start going up into other type of cloud infrastructure to have that compute. So it's about trying to model buying the base, renting the spike, and then so as your product starts to mature, that's when you start to look at what does my overall deployment scheme need to look like.
Second question, if I may.
Sure.
Like below, you've been really talking at a sort of massive infrastructure deployment level. Mm-hmm. There's a number of kind of competing reference architectures underneath that. Microsoft has their IoT architecture,
mm-hmm.
Cisco has theirs. The EU, there's a big effort there. Do you see any one of those kind of being prevailing sort of application or solution reference architecture underneath the massive scalability?
So not yet. And so if you look at, if it's an enterprise-based IoT function, I would say Microsoft has a lot of traction just based on their enterprise penetration. If you're looking at R&D holistic access, AWS becomes very significant. Google, on the other hand, it's very specific for certain capabilities that they're rolling out there. But AWS and Microsoft are the ones we see the most penetration in right now, but it depends on what that service capability is and what they're trying to roll out.
Time for one more question.
Yep, sure.
I have a question.
Sure.
Can you share your thoughts on the role that sports layer in this solution has for providers such as Verizon, Orange, and AT&T? Aside from just sitting back, saying, here's my network, use it as you choose for your IoT use cases,
Mm-hmm.
what role, opportunities do you see for that layer right now?
So over the past several years, we've seen that role become a lot more significant with the access to different API type capabilities. So the traditional model was, the Telcordia standards, process circuits, like you just said, hey, we're going to process circuits and roll them out. What we've seen with several of the providers is they're building this app suite that's almost like a portal interface where you can come in and you can grab connectivity, SD-WAN type services, where you can say, I need this type of bandwidth for this period of time, and that's all. you know what I mean, and you could bring it up and shut it down. It's still in development, but they're becoming more attuned to being flexible across this than just saying, this is your network, these are the point-to-point circuits or the internet, and that's it. So they're starting to emerge, and they're seeing that. A lot of what's happened in the SD-WAN space with companies, like Viptela and Ariaka have helped drive that. So they're looking at this going, I have the ability to help become a far more influential in an IoT deployment than just being that quote-unquote dumb pipe.
Thank you, Ryan. Appreciate it.
Thanks, everybody. Appreciate it.
As a token of appreciation, a small gift.